Hi everybody, today we are going to see the examples related to addition principle. Here the first example is in a survey of 400 students in a school, 100 were listed as taking apple juice, 150 as taking orange juice and 75 were listed as taking both apple as well as orange juice. First off, we have to find how many students were taking neither apple juice nor orange juice. In this example, first we define a set related to given example. In this example, it is given that it is a survey of 400 students in a school. So we take U as a universal set, which denote as set of survey student. Okay, next A denote set of students taking apple juice. Students taking apple juice. And set B as set of student taking orange juice. Okay, so here we define first universal set, and in that universal set from the given data there are only two sets which we have to define, which is a student taking apple juice and a student taking orange juice. Okay, now from the given example we can write the values of n of u is equal to here the total survey of 400 student is done, so n of u is equal to 400. Okay, next in question given that 100 were listed as taking apple juice, so n of a set of student taking apple juice, which is denoted by a, so n of a will be equal to 100. Okay, next 150 as taking orange juice, so n of b is equal to 150, and 75 were listed as taking both apple as well as orange juice, as well as, it is as well as, so n of a intersection b, which is equal to given 75. Okay, next we have to find how many students were taking neither apple juice nor orange juice. That is, we have to find n of a complement intersection b complement, which we have to find out. Okay, we made it as a question mark, or you may also written it as n of a union b bracket complement, which is our De Morgan's law also. Okay, now if we see the Venn diagram for such types of example, so here is our Venn diagram. Here A is a set of apple juice and B for orange juice. Now what we have to find? We have to find students were taking neither apple juice nor orange juice, which is we define by a shaded region as like this, which we have to find. Okay, this region we have to find, that is which not come in both apple and orange juice. Okay, set of, so here first we find A union B, so n of A union B is equal to, which is n of A union B is equal to n of A plus n of B minus n of A intersection B, which will give us as n of A is equal to n of A union B, which we have to find n of A is equal to 100 plus n of B is equal to 150 and n of A intersection B is equal to 75, which gives 250 minus 75, which is equal to 175, which is our n of A union B. Okay. Now here we have to find n of A complement intersection B complement, which means n of A union B complement. Okay. Now from Venn diagram, this is our Venn diagram, you can write A union B complement as n of A union B bracket complement is equal to, here this is our universal set. Okay. And from n of U we have to minus which region we have to subtract, n of A union B, so that we can get n of A union B complement. So we have a formula, n of U is equal to n of A union B complement is equal to n of U minus n of A union B. Okay. And n of n of U is given as a 400 and n of A union B is equal to 175, which we find. So its solution will be 2 to 5, which is our n of A union B complement. That is, or hence 225 students were taking neither apple nor orange juice. Okay, so we have get and required answer. Now from this Venn diagram also we can solve this example. Here intersection is 75, so it is given as 75. Okay, here it is 75. Now total A is our 100, so remaining part of A will be here 25, and remaining part of B, it is 150 minus 75, it will be 75. Okay, so total of this, it is 75 plus 25, which is 175, and U is our 400 minus 175, which will gives 225. Okay, when you are doing with Venn diagram, first start with common part of all sets. So here common part of all set is 75. After that remaining part of that set you have to define, or combined two intersection if there, you have to find that, and after that we get a required solution. Okay, now we consider a next example. Now in this example there are 200 individuals with a skin disorder. 120 had been exposed to chemical C1, 50 to chemical C2, and 30 to both the chemical C1 and C2. Find the number of individuals exposed to chemical C1 but not chemical C2, chemical C2 but not chemical C1, and chemical C1 or chemical C2. Okay, this is our question. So in solution, first we have to define a universal set. Okay, so here U be the universal set. U is a universal set consisting of individual set of set consisting of individuals with skin disorder, Okay, next here we define set A, set of individuals exposed to chemical C1, This data we write from a question only. Here 120 had been exposed due to chemical C1, so we write a set of individuals exposed to chemical C1, and set B as set of individual exposed to chemical C2. Okay. Now from question we write n of u is equal to, now here 200 individuals with skin disorder, so here n of u is equal to 200. Next 120 had been exposed due to chemical C1, so n of a is equal to 120. Next n of b is equal to here 50 to chemical C2, so n of b is equal to 50, and n of here 30 to both the chemical C1 and C2, so n of A intersection B is equal to 30. Okay, this is our given data. Okay, now first question is to find chemical C1 but not chemical C2. Chemical C1 but not C2. Chemical C2. Okay, if we see the Venn diagram of this question, here U is a universal set and there are two sets A and B. Okay, these are two sets A and B. Now here we have to find chemical C1 but not chemical C2, that is we define by its shaded region. So here A but not C, so we have to subtract common part from A. Okay, therefore we can define a formula. What we have to find? N of A minus B. So N of A minus B can be written as A minus B is equal to N of A, which is total this. Okay, total set A, and from that we have to subtract the common part of A and B, that is minus N of A intersection B. Okay, which gives N of A is 120 minus N of A intersection B is 30. So we get N of A minus B is equal to N of A minus B is equal to 90. Okay, which is our first answer. That is, number of individuals exposed to chemical C1 but not chemical C2 is 90. Similarly, for second, we have to find chemical C2 but not C1. So in this we have to find B minus A. Okay, chemical C2 but not C1, that is we have to find N of B minus A. So here the formula will be, for N of A minus B it is N of A minus N of A intersection B. Now for N of B minus A, which means this region, okay, so we have to subtract N of B minus A intersection B. N of A intersection B. So N of B is 50 minus N of A intersection B is 30, so which is equal to 20. So that N of B minus A will be our answer, which is equal to 20. That is, number of individuals exposed to chemical C2 but not C1 is 20. Now third is chemical C1 or chemical C2, that is we have to find N of A union B, which is N of A union B formula is N of A plus N of B minus N of A intersection B. So here N of A is given as 120 plus N of B is 50 minus N of A intersection B is 30. Okay, so required answer is 170 minus 30, which is equal to 140. So N of A union B is equal to 140. That is, number of individuals exposed to chemical C1 or C2 is 140. Now here in this example, in a survey of 60 people, that is here U is a survey of people's reading newspaper, because it is all about newspaper. or you can say that only survey of peoples also. Okay, now it was found that 25 people read newspaper each. So we define first set A as people reading newspaper each. Okay, next it is given that 26 read newspaper T. So people reading newspaper T, and 26 read newspaper I. So here there are three sets. Okay, H, T and I. Okay, so next we can find value of U, N of U. From question it is given that 60 people survey is there, so N of U is equal to 60. Next it is was found that 25 people read newspaper H, so N of A is equal to 25. N of B is equal to read newspaper T, which is 26. N of C is equal to, again it is 26 newspaper read I, so it is again 26. Next 9 read both H and I. So here H and I are set A and C. So N of A intersection C, which is given as 9 read both H and I. So it is 9. Next N of 11 both H and T. So H and T, which is A intersection B, is equal to, from question it is 11. And N of remaining is T and I, which is B and C, which is B intersection C, which is equal to 8. And last it was given that 3 read all 3 newspaper. Okay, so that is N of A intersection B intersection C is equal to 3. Okay, that is 3 people read all of the 3 paper H, T and I. Okay, now we have to find the number of people who read at least one of the newspaper. At least, that is, we have to find at least one, means the people may read paper H, paper T or I. That is, we have to find the people who read one of this paper. Okay, so we have to find N of A union B union C. Okay, in this set we can find people who read at least one paper and maximum 3 papers also. Okay, so first we have to find N of A union B union C. So first formula for 3 set is N of A union B union C is equal to, first N of single set, N of A plus N of B plus N of C, minus intersection of both sets, pair of set A intersection B plus N of A intersection C plus N of B intersection C. Okay, bracket complete, and plus intersection of all 3 A intersection B intersection C. Okay, this is a formula of N of A union B union C, that is addition principle on 3 set. So we write all the values from above. So here N of A is equal to 25, N of B is equal to 26 plus N of C, sorry, here it is N of C. N of C is equal to again 26 minus A intersection B is 11 plus A intersection C is 9 plus 8 and plus A intersection B intersection C is 3. Okay, which gives us 25 plus 26 plus 26 is 77 minus, it is, we write as directly it as 11 minus 11 plus 9 20 plus 8 28, which is minus, so it is minus 28 and plus 3. So here we get total calculation as 52, which is N of A union B union C, that is people, number of people reading at least one paper are 52. Q is 52. Okay, this is our first solution in this question. Okay, next, second, we have to find number of people who read exactly one newspaper. We have to find number of peoples who read exactly one paper. So we solve this by Venn diagram, with the help of Venn diagram. So here Venn diagram will be for three sets. This is our universal set. This is set A. This is set B. And it is our set C. Okay. Now, from the given data, as with data is given, we write here it again, n of A. So here it is the given data. Now from intersection part, common part of 3 set is 3. So we write it from common part. So this value is here 3. Now A intersection B, total A intersection B is 11. In that 3 is covered. So remaining part is 11 minus 3 will be 8. Okay, here it will be 8. Now similarly B intersection C is 8. 8 minus 3 will be 5. Also for A intersection C it is 9. So its remaining part is 3 minus 9. 9 minus 3 is 6. Okay, so these are the values in sets. Okay, now remaining part of A. Here total A is 25 and here common part contains 8 plus 3 plus 6, which is 9 plus 8, which is 17, and 17 minus 25 minus 17 is 8. So it is our remaining part of A. Now similarly for B, it will be 8 plus 3 plus 5, which is 11, plus 5 is 16, and 26 minus 16 is 10. Okay, and here of C, 6 plus 3 9, 9 plus 5 is 14, and 26 minus 14 is 12. Okay, and universal set U will be, here we have to find n of A union B union C is equal to 52, and here n of U is equal to 60. So its remaining part, which is not in set A, B and C, is 8. Okay, which are the peoples who do not read any one of newspaper, which do not read newspaper are 8 persons. Okay, now we have given the questions number of people who read exactly one paper. Okay, from this Venn diagram, if you see this part of A, which is 8, which is A minus B plus C, or we can say that A intersection B complement intersection C complement part is A. That is people who read only paper H. Okay, so here we can write it as the people who read only newspaper H. Okay, people who read only newspaper H is equal to 8, because this is its common, which is not in set B and set C. Okay, so it is denoted by n of A intersection. It is intersection of A, intersection of B complement, intersection of C complement. Okay, which is equal to 8. Okay, similarly people who read only newspaper T, which is equal to, which we have defined by set B, is here, which is equal to 10, which can be defined as n of A complement intersection B intersection C complement. Okay, which is equal to 10, which are people who read only newspaper T. Similarly, people who only read newspaper I is 12. So also people who read only newspaper I is equal to 12, which is n of A complement intersection B complement intersection C is equal to 12. Okay, so number of people who read exactly one newspaper is equal to n of A intersection B complement intersection C complement plus n of A complement intersection B intersection C complement plus n of A complement intersection B complement intersection C. So here the values are 8 plus 10 plus 12. 8 plus 10 plus 12, which is equal to 8 plus 12 is 20 plus 10, which is equal to 30, which are number of peoples reading only one newspaper. Okay, which is our required solution. In this example, we also find a paper who exactly read two papers only. Okay, for that we have to add this 8 plus 6 plus 5. Okay, number of peoples who exactly read two newspapers. In this newspaper, people who read H is A, H and T will be 8, H and I will be 6, and T and I will be 5. So 8 plus 6 plus 5, which is 14 plus 5, 19. 19 peoples will be read exactly two papers. Okay, and 8 peoples who do not read any of the newspapers. Okay, so by Venn diagram we can find all type of question. So first we represent it in rough, or we can write near answer and you can solve it easily. Okay. Next example. In a survey, it was found that 21 people like product A, 26 product like B, 29 like product C. If 14 people like product A and B, 12 people like product C and A, 14 people like product B and C, and 8 liked all 3 products, find how many like product C only. Okay, we have to find how many people who like product C only. So here set A, we have to define set A as people like product A. Okay, B as people like product B, and C as people like product C. Okay, now here n of A, which is given as 21 people likes product A. Next 26, n of B is equal to 26 like product B, 29 like C, that is n of C is equal to 29. Next 14 people like product A and B, that is n of A intersection B is equal to 14. Next n of 12 people like product C and A, so n of A intersection C is equal to 12, and n of B intersection C is equal to 14, and last 8 like all product, which is n of A intersection B intersection C is equal to, which is 8. Okay, we draw a Venn diagram related to the given data. Here there are 3 sets, A, B and C. Okay, A set, B set and C set. Okay, we start from intersection of all 3, which is 8. Here it is 8, common part of A, B, C. Next A intersection B is 14, so 14 minus 8, it remains only 6 here. Next similarly B intersection C is 14, 14 minus 8, it is again 6, and similarly A intersection C is 12, 12 minus 8 is 4. Okay, now remaining part of set A. Now here A will be 8 plus 4 plus 6, which is 18, and A is given as 21. Okay, so 18 minus 21, 21 minus 18 is 3. Similarly, 6 plus 8 plus 6 is 20, and B is 26, so it's remain only 6 outside this common part. And similarly for C, so here it is 12 plus 18, 29 minus 18, it is 11. Okay, so this is our Venn diagram. We represent all this part in our Venn diagram. Now we have a question. We have to find a product like people who like product C only. That is, we have to find this. Okay, which have by Venn diagram we can directly say it as 11. Okay, now so we have to find a formula for it. That is, we have to find here to find people who like only product C. Okay, this is we have to find. That is n of, here we have to find this C, which is A complement intersection B complement intersection C. That is common of, it is C total, and intersection which is A complement is outside A, B complement is outside B. So this is a common region of A complement, B complement and C. So which can be written as, now from C, n of C minus, we have this common part which is A intersection C, n of A intersection C minus here n of B intersection C. Okay, minus n of B intersection C plus n of A intersection B intersection C, because in A intersection B, A intersection C, this is our part, and this is, and B intersection C, this is our common part. So we have to add this part so that we can get a required answer. So here, which gives 29 minus 12 minus 14 plus 8, which is equal to 29 plus 8 is 37, and minus 12 minus 14 is minus 26, which gives 11. That is n of A complement intersection B complement intersection C. Okay, that is people who only like product C. Okay, similarly for homework you have a question to find first people who like only B, okay, product B, and people who like product C only. Okay, these are the two questions which you have to solve for homework part. Okay, so we stop here for today. Thank you.